So this is the second lesson on basic unit, which is a unit that deals with basic stuff that you need to know on Physics 20. And the focus of this lesson will be finding the component. How can we describe a vector? So the focus of this unit will be how can we describe a vector? And how can we find the components? Finding components. So the very first thing that we will discuss today is that we will see what is a vector and what is a scalar quantity. There are two quantities that we discuss and talk in physics, a vector quantity and a scalar quantity. A scalar quantity is the one that you fully describe it, you give the description of the quantity that you are dealing with when you are stating the magnitude of this quantity, magnitude of this quantity. When we are talking about a scalar quantity, then we are talking about quantities like time or speed, or distance. And even when we are saying energy is the same thing, we are talking about a scalar quantity. And in fully to describe this quantity, what do we need is just to say that you are driving for 2 hours. In which direction you are going, there is no need to say it. It's fully described. You know that you are starting at a certain time and you have been driving for 2 hours. Or when we are saying the speed, when we are mentioning that a certain person is walking with a speed of, let's say, 20 meters per second. Where is it going and how is it moving? In which direction is it going? Doesn't really matter. As you see here, a scalar quantity is fully described when we are saying that the numerical value, which is known as the magnitude of the quantity, and the units. The units helps a lot, especially if we want to have a clue of what quantity we are talking about. Because when we talk about time, time has the units of seconds or hours or minutes on that realm. Speed has the units of meters per second, and those are the international system units, but sometimes we use it as kilometers per hour. And then distance has the units of meter, and sometimes we use kilometers, millimeters, centimeters, but the international system unit for distance is meters. And the energy is a quantity that you have been talking a lot in previous courses of science, but even now we will talk again, has taken the units of joules, their own units, but actually are newtons per meters or kilograms meters squared per second squared. In a difference with vector quantity, in order to fully describe it, we have to state what is the magnitude, so that numerical value, magnitude of the quantity, And what is the direction? So in order to fully describe a vector quantity, you need to state what is the magnitude of it. So that numerical value, 20, 15, 2 hours, 2 meters per second, and so on. But you have to state the direction. The direction can be stated in different ways, but in order to fully describe a vector quantity, you need to have both of those parts. This is a table where it's showing some of the vector quantities that we will use in physics and some of the scalar quantities that we will use. Sometimes they are correlated with each other, and very often, especially students that do not take physics, have messing them up with each other. So instead of talking about the velocity, they talk about speed, or instead of talking about displacement, they talk about distance, because they are, let's say, corresponding quantities of vectors and scalars. So the units for either speed and velocity, international system unit for speed or velocity, are in meters per second. And the international system unit for displacement is in meters. Force doesn't have a corresponding quantity on the scalar column. And the units for force are newtons. Acceleration is another vector quantity, and the units for acceleration are meters per second squared. Now, velocity is known with, in physics 20 here in Canada, with a V and this little R on top, which tells you that you are dealing with a vector quantity, while speed is just the lowercase v. And displacement is known with letter D with a vector on top, and again, that vector on top means that you are dealing with a vector quantity, and distance is just the letter D. Forces are with F, letter F, capital F, because they are different type of forces, which we will talk a lot when we go to the second unit, dynamics. And then we use the subscript to identify what type of forces you are dealing with. You know that time is with a lowercase t, and acceleration is with a letter lowercase a and the vector sign on top. Okay, so when we are making the distinguish between what quantity is this, is a vector or is a scalar quantity, the question that you will ask is, when I'm describing this quantity, do I need any direction to add to this quantity or not? And if not, then is a scalar. If yes, then is a vector. On the other hand, work and energy, as we said, energy is with letter E, and then we use the subscript K or P or S for kinetic, potential, or spring, and work is assigned with a letter W, and the units for it, as we mentioned, is joules or newtons times meters or kilograms meter squared per second squared. Okay, Do you have any question regarding this? So as we mentioned, in order to fully describe a vector, quantity, you should to define what is the magnitude, that numerical value, and I always say along with units, unless we are doing something to really understand the concept. And you always will see and will hear me saying this vector A with magnitude 20 meters per second. Unless, as I said, we are doing something that the units doesn't really matter for that particular question, because we want to get to the basics of how to operate with vectors. The magnitude is the length of the line segment that represent the vector. So when we are working with a vector, what you will see, we will see me very often working like this, saying that this is a vector D with magnitude 20 meters, and it has a direction of 30 degrees north of east. So the length of this line segment that represents the vector. So what is this line segment here? It is representing that 20 meters. And then the direction is based on the angle that you see here. Okay, so when we are saying that the magnitude is the length of the line segment, we are talking about what is this length of this line segment that represents the vector. And if we take another vector, let's say a vector D2 now, if this is D1, then D2 has 15 meters, and it is with an angle of 70 degrees. Then the length of this line segment here will represent the 15 meters. Okay, there are different ways to describe a vector. In terms of the direction, because we established that the magnitude is the length of the line segment that represent the vector. But now, in order to describe a vector, we need to know what is the magnitude and what is the direction. So now the direction part is defined in different ways. The first way is that is known as the bearing. Okay, bearing is the angle with the north axis. But when we are moving in clockwise direction. So if we have a vector that is with a 50 newtons at 240 degrees of bearing, then what we are doing is, this is the north axis, and then 240 degrees with north axis in the clockwise direction will be somewhere in here. So vector B with 50 newtons at 240 degrees of bearing will be this vector here. If we have another one, let's say that we have a vector A with magnitude of 30 meters per second at 100 and I don't know 120 degrees with bearing, then the way that we will represent it is something like this. This being north axis, and then what we have is 120 degrees. So 120 degrees is somewhere in here, 120 degrees. And the vector is 30 meters per second. Understand? Now, the second way to describe the direction of a vector is by using direction of a vector is by using the positive x-axis. And when we say the positive x-axis, keep in mind is the same as the convention that we are using in math. In math, we are using Cartesian axis, so it is x and y axis, and x is positive on the right, and y is positive up, and then the rest of them are negative. So y going down is negative, and x going to the left is positive. Now, a different way to describe a vector in terms of the direction is by taking the positive axis. So this is the positive axis, positive x-axis, and then the angle that is created between the positive x-axis and the vector in the directional counterclockwise is taken into the consideration. So if we have a situation when we have a vector C that is with a magnitude of 24 newtons at 130 degrees with a positive x-axis, that means that the way that we will represent this will be something like this. This is the positive x-axis. And then 130 degrees with a positive x-axis will be an angle in counterclockwise direction. Will be an angle that looks like this. So the vector that represent vectors, or the line that represent vector C will be this one here, 24 newtons. Even if we have something like a vector D that is with a magnitude of 15 newtons at 52 degrees with positive x-axis, the way that we will represent this vector is we will draw the positive x-axis here. And then we will say, what is 52, sorry. 52 is somewhere in here in counterclockwise direction. So this will be 52 degrees, and the magnitude of this vector D is 15 newtons. Okay, those two ways are not used as often in physics, but you need to know how to describe and how to represent a vector even if you have this kind of situation. The bearing is used especially in navigation, while the positive x direction is used in mostly on engineering. However, the third method is the one that is used widely on the physics world. The third way to describe a vector And when we are saying, again, describing a vector, we are focusing now on the direction part of it, because the magnitude is the line segment of this vector. Is when we, so again, review, in order to fully describe it, we need to describe the magnitude, and this is important, guys. Especially if you see me repeating something often, then that means that this is important. Okay, so now when we have a vector A that is 12.5 meters per second at 32 degrees north of east, this part here is the magnitude of the vector. And whatever is coming after the at is the direction. Again, in any way that we work and describe a vector, the magnitude is the length of the line segment of the vector. When we draw a vector, then the length of this line segment that is representing the vector, length, is telling us what is the magnitude. The direction, as you see, has two parts. Has the angle, and it has the relation with the northeast southwest axis. Okay, and this is mostly what we will use on physics. Okay, now let's talk a bit about this. What is the northeast southwest axis? How can we represent the northeast southwest axis? Okay, if the magnitude is telling us what is the length of the line segment, the angle is telling us what is the angle with either northeast, south, west axis. Now the question, natural question actually, will be, okay, well, how will I know where this vector is lying at? Is it northeast? Okay, but this 32 degrees is with north or is with east? So in order to know this, what do you have to do is you have to ask yourself some questions. And now, the first question that you will ask is, where is the vector going? So, and then the answer to that question will be the first letter. So where is the vector going? So now the answer to this question will be it's going north. Good. And now the other, to go north, you have two options. You have the option to go from east, and you have the option to go from west. And now the second question that you will ask will be giving the answer to the second letter. So it will be starting from which point? Which point? And it is starting from east. So in a way, what I tell my students is when you are reading a vector, you are reading it like this. Vector A with magnitude of 12.5 meters per second at 32 degrees north of east. So you are reading it on this direction. And when you are drawing it into northeast southwest axis, you will start in the opposite direction. So you will say, starting from east, going north at 32 degrees, you are drawing a vector with magnitude of 12.5 meters per second, and this is vector A. What do I mean by this? Northeast southwest axis look like this, northeast southwest axis. So now you are starting from east, means you are starting here. You are going north, so you are going on this direction at 32 degrees, with a magnitude of 12.5 meters per second. And this is vector A. Does it make sense? So now let's suppose that we have a vector A that is with magnitude of 50 newtons at 50 degrees south of east. How will you draw something like this? Again, when we are reading it as in normal English, from left to right, okay? From left to right. But when we are drawing it starting from right to left. So what does that mean? Here is northeast southwest axis. You are talking about a vector that is starting from east. It's starting from east, going south at 50 degrees. So this will be 50 degrees. The vector is with a magnitude of 50 newtons. So vector A with magnitude of 50 newtons. Okay, let's take another example. Let's say that we are dealing now with a vector B that has a magnitude of 20 newtons at 57 degrees south of west. Okay, so the vector is between south and west. You may draw all the axes, or you may just draw south and west axis. And then it's starting from west, moving at 57 degrees. So this is 57 degrees with a magnitude of 20 newtons. And this is how we represent this vector. Is it clear? Do you have questions? Okay. So let's suppose that we have now a vector C that is 18 newtons at 20 degrees west of north. So it is starting from north, going to west at 20 degrees with a magnitude of 18 newtons. So you can draw the north and west axis only, or you can draw all four. So north is here and west is here. It is starting from north, so it's starting here. It is moving at 20 degrees in the west direction. It has a magnitude of 18 newtons, and this is vector C. There are some cases, though, where we just don't say the angle. So those are unique cases, and The first one is when we are right in the middle. So as you know, northeast, southwest axis form in between each other 90-degree angle. So when we are in the middle, is 45. If you see a vector E that is with magnitude of 27 newtons northeast, that means that the angle is 45 degrees. So it's right in the middle of north and east quadrant. The way that we will draw it will be north here, east here, and then the vector is at 45 degrees. With which axis doesn't really matter. You can draw it with north or you can draw it with east, will give you the same result. And this is vector E with magnitude of 27 newtons. Another case where we do not mention the angle is when it is due to one of the axes. So if we have a vector F that is with magnitude of 35 newtons, and then we say due south, then the way that we represent this vector is a vector that is straight south. So it's a vector that goes like this. And the magnitude or the line segment is 35, representing 35 newtons. So you can have this situation with all four axes. You can have a vector G that is with magnitude of 18 newtons due east, and then the way that we represent this vector is just like this, going straight east. As you see here, we do not state the angle. Or if we have a vector that is vector M, that is with magnitude of 15 newtons due west, then the way that you will represent it is a vector that goes like this with magnitude of 15 newtons, or a vector N with magnitude of 22 newtons, but now is due north. Then the way that we represent it is just going straight north, 22 newtons. Is this clear? Do you have any questions? Okay.